Hi, welcome to solveandgo.com. I'm going to continue with a series of videos giving solutions to the Math 135 final exam from 2010. This video shows the solution for question number 8. So this is about finding a local maximum. The question is, so we're given the function f of x equals 12x squared minus 5x cubed plus, it's 12x to the power of 5 minus 5x cubed plus 2 has a local max, has a local max. Pen is giving me trouble. Give me a second while I switch pens. Has a local max at question mark. Okay, so what we're going to do is take the first derivative and find the critical points. Okay, so f prime of x equals, so 12 times 5 is 60, x to the power of 4 minus 15x squared. And then we need the critical points. So we're going to solve for when this is 0. So let me factor it. We have a common factor of x squared here. It's x squared times 60x squared minus 15. And then we set that equal to 0 and solve for x to find the critical points. Okay, so one solution we see is x equals 0. And the other, well, we have 60x squared minus 15 is 0. And so that gives x squared equals 15 over 60, which is 1 over 4. And so from here, we get x equals plus or minus 1 over 2. Okay, so let me list the critical points here. So the critical points are x equals 0, x equals plus a half, and x equals minus a half. And we have to find out which one is a maximum. So what I'm going to do is use the second derivative test. Okay, so let me erase this. I'm going to keep the derivative here because we're going to need it. So we have f prime of x, and f double prime of x ends up being, so 60 times 4 is 240, x cubed minus 30x. And we're going to use the second derivative test. So we're going to plug in the critical points into the second derivative. So f double prime at 0 is 0. F double prime at a half is 240 times a half cubed, which is 1 over 8, minus 30 times a half, which ends up being, so 240 over 8 is 30, so we get 30 minus 15 is 15. Okay, so let's see where we are so far. We still have one more critical point to plug in, but we saw at 0, the second derivative was 0. So here we have no info. That's part of the second derivative test. If the second derivative ends up being 0, it gives you no information about whether the critical point is a max or a min, or neither. We know x equals a half. At x equals a half, the second derivative is positive. Okay, it was 15. So since it's positive, this tells us that 15 is a minimum. So we can cross x equals a half out as a possible max. And let's try x equals negative a half. So I'm going to have to erase this here. What we do is we plug x equals negative a half into our second derivative. F double prime at negative 1/2 is 240 times negative 1/8 over 8. So it's minus and minus, so that's plus 30 times a half. Okay, I just cancel the negative signs there. And what we end up getting is negative 30 plus 15, which is negative 15, which is less than 0. Okay, so since the second derivative at x equals negative 1/2 is less than 0, and that's a critical point, this tells us by the second derivative test, we know that x equals negative 1/2 is the local max. Okay, so that's the answer and solution to problem number 8.